Hello everyone, we're going to talk about place value and the base 10 system. I'm sure you've done this since elementary school, talking about place value, and you have the ones place and the tens place and the hundreds place. But I want to kind of talk about it in a little bit different way now that you know about exponents, and also want to talk about some other base systems that have existed in history and exist now. So the ones place, it's really, we just go through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then we have a whole 10, so then we go to the next spot over the tens place, and we have 1 10 and 1. So that's 11, 12, 13, 14, 15, 16, and so on. And then we get another 10, and that goes up to 2, right? So that's how the base 10 system works. And I think it has come to wide use because we have 10 fingers to count on. So we count up, and other systems have existed where it was base 12. The Egyptians used base 20. The Chinese used base 16. If you ever see an abacus, that's based on the base 16 system. And even English, we have used in the past base 12 with inches, and of course the clock. You know, the clock has 12 on it, and even today we use it in the modern computer because it's much easier mechanically to have either something go on or off. So this is like if it's on, it's a 1, and if it's off, it's a 0. So it's very easy to use a base 2 system with computers because it's a mechanical system. So what does that mean for exponents? So to figure out what this number means in the hundreds place, that would be 10 squared, right? How many hundreds do you have? It's how many 10 squared. How many tens do you have? That's 10 to the first. How many ones do you have? That's 10 to the 0. And we even go backwards in the decimal system. We go back to tenths, right? How many tenths are there? So that would go backwards to the minus 1, and which is the same as 1/10, right? 1 over 10. So that's how place value works in the base 10 system. So let me just give you an example. How about we have the number 256. Okay, so what is that break down to? Well, it's 2 times 10 squared plus 5 times 10 to the first plus 6 times 10 to the 0. Right? And if I wanted to do something like 352, let's make it a decimal. So 0.352. So this would be 3 times 10 to the minus 1 plus 5 times 10 to the minus 2 plus 2 times 10 to the minus 3. So that's how place value works using these exponents. If you wanted to use place value in a computer system, for example, so like let's say we had this number right here, 101101. What is this number in base 10? Well, all we do is go along and look at each part. So this is like 2 to the 0th. This is 2 to the first, and 2 to the second, and so on. So what we have here is this ones place means it's a 1 plus 2 to the 0, right? Plus, and we have no 2 to the first place. We have 1, 2 squared, and then we have 1, 2 cubed, and then we have no 2 to the fourth, but we have a 2 to the fifth. Okay, so this is 32. This is 1 plus 4 plus 8 plus 2. This would be 8, 16. We skip, and then 32. Yeah. So this number 101101 is equivalent to in base 10. 32 plus 8, which is 45. So that's how the bases work. Is each spot is another exponent. So 2 to the 0, to the first, 2 to the second. I quite like the base 12 system because it makes things easier for division, because in base 10 we can't divide things by 3, right? Or we get this repeating decimal, right? 1/3 is 0.3333, and so on. But if we were in base 12, if we divide things by 3, it would just be 0.3. But then it's kind of confusing to people that haven't grown up with base 12, because we have to add a couple more letters, right? So we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And instead of 10 going to that next place, we have to make up a new letter. So for base 12, we will use X for 10 and E for 11. And then for 12, 12 would be the next place over. Okay, so this is a little bit confusing to people that haven't grown up with it. But if we grew up this way, using base 12, it would probably be a better system to use, because it'd be nicer for division. But anyway, that's why the Babylonians probably used it, was they could divide a lot of things. Like if you want to divide things into thirds, if you want to divide it into fourths, if you want to divide it in half, it still works, because 12 can be divided up in many different ways. And I think the way that they probably counted was on the segments of their fingers. And instead of counting with their fingers, they counted with the segments of the fingers. So they counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you can see that you could divide it into 2, 6, and 6. Or you could divide it into 4, 3, 3, and 3. Or you could divide it into 3 parts, 4, 4, and 4. And so it's kind of neat that way. Okay, so that's what you're going to do, is break these things down into their placeholders in the base 10 system. And we'll get on to units in the next video.